Hello, it's been a while. Just haven't been recording a lot of these videos, but I have been incredibly busy and I have been working on this pattern. Today I'm going to cover the iterator pattern. And this is a pattern that I personally was kind of confused on. I didn't understand, why are we having this completely separate interface class to kind of go through a data structure, a collection, a list, like what's the point, what's the purpose. But as I started to go through and develop and work through databases and other kind of objects in Java, Python, and understanding the complexities of a collection, and also understanding how iteration can be varied in many different contexts and domains, I started to realize, okay, there is a reason why we have this template interface class rather than just going through and looping through a list, because it's not always going to be a predictable data structure, database, object, and it's not always going to be predictable in how we are going to traverse into a collection. And so I think I have found the perfect example and we'll demo it. But this demo, forewarning, will require some deeper look into it. I modeled this demo after a very popular LeetCode question, the LRU cache, least recently used cache. And so I'm not going to go into depth explaining what that is, but I will go through at least why this pattern is used for this specific case. And I'll focus more on that. So, all right, let's get right into it. Okay, so we're going to just look first at this demo. And like I said, I'm going to try really hard not to go into the weeds. There's a lot of specific details on what LRU cache is. So the whole purpose of this is just to demonstrate that there is this very complex data structure that is constantly changing through iteration, through adding, through getting. And so we're going to first start by saying the capacity to 3. And so we're going to add the values, the key. So it's a cache, it takes a key, it takes a value. And so we can see that as we add those values, when we print out the cache, we get kind of this linked list type thing. And these are the values that are in our cache: C3, B2, A1. And as we can see, once we get a value, this is our get function. If we got B, then we notice that the cache will change. Now B is up here, A is over here. And then if we got A here and printed the cache again, we can see that it would change here. A is here, B is here, C is here. Now this is just a very brief explanation, and that kind of goes into why this is a popular LeetCode question. But also, if we add a new value, let's say we added E5, we can see that whatever was here, C is gone. And so if we got C, there would be a -1 because it doesn't exist. So the whole purpose of demonstrating this is just seeing that there is a very complex data structure here that constantly is changing no matter what we do. We add a value, the data structure will change. We get a value, the data structure will change. So when we print the cache, we want to iterate through this data structure without affecting it or affecting all the complexity that is located within this data structure. And so as we kind of go into this code here, let's look at more specifically this class here, this iterator. Now, just to highlight, this cache here contains another data structure here called a linked list. And the linked list is going to go through and use this node. So it's just a very typical linked list that has a head, a tail, though, that we use to code out this cache. But what's really important to see and understand here is not all the details on the data structure, but understanding that we have separated a lot of the iteration away from this data structure, from this cache. And the cache does have the gets, but I wanted to just mainly focus on using the iterator and using a concrete iterator here to go through and print out the list and add a lot of the functionality within this demo. Because a key problem that we face in this cache right here is that if we look at this get function here, anytime we get from the cache, it will affect the entire cache in itself. So you see here, there is some sort of manipulation on the data structure itself as it gets a new value. If we put something into this cache, it will have this automatic effect as well. And so there is some sort of separation abstraction that we want to create by iterating into the cache, but we do not want to affect it in any sort of way in manipulating, adding, and creating this sort of hot mess as it comes through. Because if we're not even talking about this specific data structure, we can talk more specifically about databases and thinking about rows, columns, and how they're organized in Java, and I think PHP as well. And so when we think about those specific examples, we might want to use an iterator because in the same vein, we want to go through that object, database, structure, whatever, and we do not want to manipulate it, to change it. We want to go through in a very specific way or in a different way. And so iterators, we have an iterator class that we know from the high level, it's going to just do something like next, has next, get current. And so those are kind of the typical functions here. Added on these more specifically because for this specific context, there is something like LRU, MRU, which is least recently used, most recently used. And so we could theoretically change the entire cache if we wanted to iterate it in a very different way. Like if we wanted to reverse the values here for some specific purpose, we're able to do that because we have this iterator class here. And so as we look at the concrete iterator, more specifically, we're creating those methods out of getting next, has next, and a big reason why we do this is also, if we think about Java, just for safety as well. We're able to have some way to create that boundary of we're only going to iterate into specific values that we want, that we know exists, and so that adds another level of safety and security in iterating through your list, and also creating some predictable iteration or a predictable manner on how you believe that you want to always iterate in some list, or maybe you create another function that might be like iterating the odd values or iterating the even values. It's not just one specific way, but it creates a specific constraint so you can make sure that in the future or even in the present, there is some sort of extra boundary and safety that is created for that specific context. And so, again, this code is a little bit complicated and confusing if you've never seen what a LRU cache is. And so I would recommend first going to LeetCode, and then also next, after you've read about it on LeetCode, going back through and kind of playing around with the demo, playing around with this code to kind of understand why this iterator is helpful for this specific data structure as well, without manipulating the underlying data structure, because again, whatever we do for getting, putting, it will affect the underlying structure. And so we want to make sure we have that not affected. So just, again, to note that what's really crucial in understanding the iterator is we're kind of abstracting away from that, going through some list collection. I keep saying collection, but it's some data structure, something that we're having some way we're storing some data within some code. We're abstracting away that iteration because we know that we're going to vary it. We might not want to affect it. There's not one specific reason or one specific context where we're always going to use the iterator. And it's kind of better to do that because it's also creating those specific boundaries and also anticipating that in the future there might be some other way that you can configure and change that iteration to whatever context may need. And that's a big part of coding and developing, being able to manipulate and change it. That was a little bit of a shorter, briefer explanation. And it's mostly because if I had to explain the cache, go through everything, it would be incredibly long. And so that would be the homework for a lot of people because that's not related to the iterator pattern. That's a whole separate topic and something I might cover. Actually, I probably won't because that's just kind of like a leak code question. So you can look it up. And if you like this content, just subscribe, go to my GitHub. I have the demos, I have the examples, I have a very thorough explanation. And so if this was not enough, you can go there and get the nitty gritty and all those details. So thank you for watching. Bye.